So let's start. We will write introduction to asynchronous JavaScript. Now we know that JavaScript is a single threaded language. This is very clear. This must be very clear that JavaScript can run or execute only one task at a time. Suppose I have a console log which says hello first, and I will copy this line and I will paste it 3 times, and this should be second. Let me make it second and third. Now if I run this code, you will see it is running one by one, which means it can only execute code one line at a time. Now that works fine for single script, but real world applications need to handle multiple things at once, like fetching data from an API, reading files from disk, responding to user interactions, or updating the UI. These are operations that can take time. And if JavaScript waited for each one to finish before moving to the next line, your entire app would feel frozen. That's where the concept of asynchronous JavaScript or asynchronous programming comes in. Okay, asynchronous JavaScript allows your program to perform non-blocking operations. What is non-blocking operations? Tasks that can run in the background while the main thread continues executing other code. Now what will actually happen after this? This keeps your applications fast, responsive, efficient, even when working with slow tasks like network requests or file operations. Okay, I hope this is very clear to you what is asynchronous programming. Now take an example of a real life developer. He is making a VS Code, okay, or any code editor. Now let's add a feature of this run button. We have this button called run code, okay, or this will run the code that we have written. Imagine when I click on this, and before the code executes, it has to do a lot of things to actually execute the program, like save the file and write the file to disk, auto format the code. These are a lot of things that the code editor has to do before executing the file. Let me show you. If I run this, it already saved my file, formatted, and now executed. A lot of things are happening here. So what's the problem here? But the problem here is, if we follow the synchronous way, the code editor would freeze for several seconds every time the user clicks on the run button. Totally unacceptable in a real application where a lot of things needs to happen simultaneously, but your application or your code editor is freezing. User will not pay for that application, or user will not simply use that application. So that's the problem. But with asynchronous behavior, these operations can be offloaded in the background while the code editor remains snappy and usable. I think this is very clear. So this was one example. Let's take another example. Example number 2, which is very common example. Example of a chef. So imagine you are working as a chef in a kitchen and you are alone in that kitchen. Just like JavaScript single threaded nature, the chef has multiple tasks, like suppose he has a task of boiling pasta, okay, and he has to do toast the breads, and also he has to chop the vegetables. Okay, he has 3 tasks to do. Now the basic thing is, if he follows the synchronous way, then what he needs to do, first he will boil the pasta, toast the bread, and chop vegetable. And if the chef waits for the pasta to boil before starting anything else, everything takes longer time. This is the synchronous behavior. But if let me comment it, if he follows the async way, what he can do here is, the chef starts boiling pasta, sets a timer, and moves on to the toast the bread and chop vegetables while waiting. That's asynchronous behavior. The chef gets more done without doing everything sequentially. He will save time and a lot of things. So that's the basic examples, and what we have learned from here is the benefit of asynchronous JavaScript, that it enables complex responsive applications in a single threaded environment. Whether you are calling an external API, handling file uploads, or managing thousands of concurrent users, you need to understand asynchronous JavaScript to write the modern production grade code. And in this tutorial, I will help you break it all down from callbacks to promises to async await with real examples and zero nonsense. So let's start. So we will move to the notes. Let me open. We have seen, I have written everything in the notes. You can read it out. We have seen this example and synchronous versus asynchronous. A lot of things are there. Now, how to know if a program is asynchronous? Very important question. If your program has APIs or functions like set timeout, set interval, or fetch, or XMLHttpRequest, file read, file write in Node.js, it is enabling to connect with database like MongoDB or SQL, or getting data using REST APIs. These are the things that shows that this program is asynchronous. Other than that, if it has only some normal console logs and simple functions, that's not asynchronous. Okay, real life example. We have already seen the chef example and VS Code example. Now we will start with the very important thing, Callstack. Let me make a file, callstack.javascript. We are done. Okay, why it is not making a JavaScript file? What's wrong with it? Extra space. Yeah, we're done here. We are here. What is Callstack? The first question that I need to answer you. The call stack is a data structure that keeps track of functions execution in JavaScript. It follows the last in first out principle. The last function that gets pushed onto the stack is the first one to be executed. So what we have understood from this definition, that call stack is a data structure that keeps track of function executions in JavaScript, and it uses stack. And what stack follows? LIFO. Okay, there is an example as well. I will copy the definition for you because I will then paste this in the VS Code so that you will get everything once I'm done teaching you, and you can get everything in a single place. So we have the definition here. Let me make it a bit smaller. Yeah, we will write a function login user. If you don't understand, don't worry, I will explain you everything in details. Okay, we will do console.log, and inside this login started. Then we will call a function called validate user. Okay, we will create it afterwards. Then again console.log login finished. Very simple. After that we will create a function validate user. Inside this we will have a console log. In that we will have validating user. Inside this we will call fetch user data, and we will create that function as well, fetch user data. Console log fetching user data from database. This much is enough. At the end we will finally call the login user. If I run this code, you will see we are getting login started, validating user, fetching user data from database, and login finished. Very simple. Okay, now to explain you this, I need to open my favorite thing, that is a drawing app which is called whiteboard. I need to open this. So simply we will create one stack. Okay, just ignore my bad drawing skill. And now what is actually happening? The program starts by calling login user. That function gets pushed onto the stack, which is login user. So we get log login user USR. So we got the login user that pushed onto the stack. inside login user, we log that login started. Okay, we got that. Let me just run it again. And the whiteboard, yeah, we got the login started printed on the console. After that, we call validate user. So validate user is pushed on top of the stack. We got validate user. Okay, we got the validate user onto the stack. Inside validate user, okay, now the third line console log login finished will not be printed. Okay, remember this. Now we are inside the validate user. This is how Callstack works. Inside that validate user, we printed the validating user. We got this, and we called fetch user data. Now fetch user data will get into the stack. Fetch user is now at the top of the stack, and we print fetching user data from database. Once that finishes, it gets popped off the stack. Let me take another color, which is red. After this, the fetch user is popped off the stack. We are now at validate user function. This is also done, so we get off or popped off the stack. Finally, we go back to login user and we logged the login finished, console log login finished, and then pop that off as well. So this is how Callstack works. Now the Callstack is empty. I hope this is very clear. So let's open the notes, and we have seen what is Callstack and how the flow actually works. I have also mentioned a simple program and execution flow, you can see. Now the very important thing in asynchronous JavaScript is Microtask Queue and Macrotask Queues. This is extremely important. You must pay attention to understand this. JavaScript's asynchronous behavior is managed by two key queues. Okay, these are queues or queue data structure. That Microtask Queue and Macrotask Queue, also known as Callback queues. These queues determine the execution order of different asynchronous operations, ensuring JavaScript remains non-blocking while efficiently handling tasks. So we have understood this, that there are two queues. One is Microtask Queue, another one is Macrotask Queue, and these are helpful in managing the asynchronous operations, and how they are doing that we will understand that using a very simple code. Okay, so first let me just move a little bit down, and we have Microtask Queue, which has high priority. Okay, remember this executed first before any macro tasks. So we will let me make a file, Microtask Queue.javascript, and so first we will understand Microtask Queue, and then we will understand Macrotask Queue. So Microtask Queue. Although I can explain you both the concepts in the same program, but I am making two programs so that you will be more comfortable to understand. So we will write one console log which will have script started. After that we will create a promise dot resolve. Do not worry about the promise. Okay, we will understand what are promises in a much detailed way. Inside this promise we will create one arrow function, console.log and Microtask1. Then we will copy this and paste it again, this time Microtask2, and again console log to end the script end. Very simple program. As per you might think that it will run sequentially, but let me show you what happened. If I run this, you can see script started, then the line number 13, which is script end, is printed, then after that Microtask1 and Microtask2. So how and why the program is behaving like this, we will understand this concept. Okay, we will open the whiteboard. So what we have seen previously, we have a call stack. So we will have a call stack, and in that call stack these console logs will be entering as a LIFO fashion. So this, let's suppose we will name it C1 or console log 1. This gets into the call stack and gets executed. Okay, then we have C2 or console log 2, C2, this one, and gets executed. Now the call stack is empty. We have learned right now with this notes that we have a Microtask Queue, which has a higher priority, which includes, remember this, very important, promises, mutation observer, queue microtasks. These things are included in the microtasks. So we are using promises here. We are using promises, we know that. So these promises should get into the queue. Very simple. So we have a microtask queue, MQ. Okay, I'm too bad in writing, but I hope you understand. This is microtask queue. This is queue. So we will have one promise. We will name it as P1. Then we will name the second promise as P2. Okay, so once the call stack is empty, remember this, the program will not directly jump into the microtask queue if the call stack is not empty yet. Once this is empty, then only the program will move to the microtask queue. So once this is empty, we have nothing in the call stack. This is CS or call stack. Once this is empty, it will ask, brother, do you have anything? So it will answer, yes brother, I have 2 promises, so I am going to execute. But before that, it will ask, brother, are you empty? Yeah, it's empty. So it will execute P1 or promise 1. Promise 1 gets resolved. We will get microtask 1. Promise 2 gets resolved. We will get microtask 2. And now microtask queue is also empty. So this is how it executes. First, the call stack gets executed and call stack is now empty. The stack is empty and it will ask microtask queue, brother, do you have anything to print? Do you have anything to execute? So it will if it has, so it will execute these 2. Very simple. As I have shown you this, the preview, let me open the notes. This microtask queue has high priority and it includes promises, mutation observer, queue microtask. Okay, let me add some another thing apart from promises. Suppose we have a queue microtask and inside this we will have arrow function which will have console log promise resolved or anything, let it be, and if I run, you will get exactly the same answer. Script started, script ended, and microtask 1 promise resolved, microtask 2. So let me open the whiteboard and let me just use this one. So the behavior is very similar of this program as well. We just have a queue microtask here, and which is Q1, and then we have promise 2, P2. Okay, again it will check if the call stack is, once the call stack is empty, it will not check actually. Once the call stack is empty, it will execute promise 1, then queue microtask, then after that it will execute the promise 2. Very simple. So this was about your microtask queue. I should name this to microtask queue and macrotask queue. Okay, inside this we will understand macro as. Let me open the notes. We have seen microtask queue which has high priority. Now we will see macrotask queue which has low priorities or lower priority. Executes after all microtasks have been completed. Used for tasks that can be deferred until later. This includes set timeout, set interval, set immediate, input output operations, UI rendering. These things are included in macrotask. Okay, so we will create one program to understand why it is low priority, why microtask has high priority, how the flow is actually working. So we will do a console log. Inside this, script started, and we will use a set timeout function. Inside this, a console log, Macrotask Queue runs, and let me give a time of 0 second. Okay, and promise, okay, P should be capital, promise dot resolve. Let me copy and paste it again. Microtask 2, again console log, script ended. Let me clear the terminal and we will run this code. Now you can see we got script started, script ended, microtask 1, microtask queue, then macrotask queue runs. Okay, technically if you see, if JavaScript does not support asynchronous programming, then it should have printed console log, set timeout, then promises, then console log simply. But we have asynchronous programming, so let me show you how the exact flow works. It doesn't matter if you make it 2 seconds as well, it will be having same output again. If I run, you can see again we are getting the same output. So what we have learned, that we have a call stack like this. Now in this program we have a Microtask queue, which is promise. We have a set timeout function which comes under Macrotask queue. Okay, so I will simply write this one is micro and this queue is your macro. So let me introduce you with the theory part again, then we will see how the flow works. We have learned Microtask queue. Remember, it has high priority. Macrotask queue, which has low priority. This includes set timeout, set immediate, and input output operations, a lot of things. Okay. So now let's see the flow of this code. We have a console log. This will get into the call stack. We know this is call stack. Okay, we know this. We have console log 1, which gets into the call stack and printed script started. Okay, we got another synchronous code which is called log script ended. So this gets into the stack C2 and script ended is printed in the terminal. Now this time what will happen, let me choose another color. This will get popped off the stack and then this one popped off the stack. Now the call stack is empty. We have a Microtask queue. Now this set timeout is a function of Macrotask, so this will be in its place, which is set timeout. This function, this should be in the Macrotask queue, and these two promises should be in the Microtask queue. Okay, P1 and P2. Very simple. What we will do now, once this is empty, once the call stack is empty, it will check the Microtask queue. Now this is the point where you should ask question why it should or why it will check the Microtask queue, why it will not check the Macrotask queue. And the answer is very simple. Microtask queue, this one has higher priority. I was telling this since I was teaching you Microtask queue. This has higher priority, so this will execute first. Then it will go for the Macrotask queue. So this answers your question. Another question that you should ask me, that who is checking these things? Like, who is that person that checks, oh okay, the call stack is empty, oh the Microtask queue is empty? Who is checking that? That person or that thing name is event loop. Okay, so event loop is a mechanism inside the JavaScript runtime, like your browser or Node.js, that constantly monitors, is the call stack empty? Are there any microtasks in the Microtask queue? Are there any macrotasks waiting in the Macrotask queue? Okay, so event loop is that mechanism. So this promise will get executed by the event loop like this. Okay, done. So promise 1, which says Microtask 1 is executed, you can see here. Now event loop will execute this one. Microtask 2 is executed. Now event loop, after this Microtask is empty, will go to Macrotask. Brother, do you have anything in the Macrotask? It will ask like this, and this will reply, yes, I have a set timeout function. This needs to be executed. After that, this set timeout will get executed. This is how the complete flow of this program. This is extremely important. If the interviewer asks you this question, how the flow works, how the Microtask queue, what is Macrotask queue, anything, please make this program and explain you the way I explain to you. This will going to be super helpful for you and for the interviewer to understand that your basics are clear. Use terminologies like event loops, which actually checking everything. Do not tell brother, do you have anything? This is my way of teaching. Do not tell this to the interviewer. Tell that my event loop is checking from call stack to Microtask queue to Macrotask queue. It is taking care of everything. Event loop is the main thing. Okay, and explain to your interviewer with this code. Very simple. I hope this Microtask Queue, Macrotask Queue, event loop, call stack, everything is extremely clear to you. So we have seen, you just need to remember what is included in the Microtask Queue. Promises, mutation observer, queue, microtask, what is included in the Macrotask Queue. Okay. I also have mentioned few programs you can see also with the complete example. Real life analogy. Think of Microtask Queue as urgent. Okay, we know this Microtask is urgent. High priority task like replying to your boss's email. Yeah, it's important, otherwise you will lose your job. While the Macrotask Queue represents less urgent tasks like checking social media. You can check social media after you reply to your boss. You finish replying to your boss first, which is Microtask Queue. Then you check social media, which is your Macrotask Queue. The next topic is callbacks. Let's start. We will create one file, callbacks.javascript. So let's understand what is callbacks. Okay, a callback is a function passed as an argument to another function. Very simple. A callback is a function passed as an argument to another function which is executed later when an operation is completed. This was the primary way of handling asynchronous operations before your promises and async await. So before we have promises and async await, we used callbacks. And this is very important and useful thing in asynchronous programming. So we will understand callbacks in a much deeper way using codes. Okay, so there is one example as well you can refer, but let me copy this definition and I will paste this here so that you can get everything in a single place. Now, what we know, a callback is a function passed as an argument to another function. Okay, very simple. So we will create callbacks. We will create some functions to simulate this. Let's create a function name fetch user data, which will have a callback. We are defining a function fetch user data that accepts a callback. Okay, so inside this we will have set timeout function. Inside this set timeout we will have some console logs, fetched user data from server, and we will have callback id as 1, name, my name Tekneikos, and this will simulate a 2000 millisecond or 2-second time. Okay, cool. So we are not doing much thing at this step. We are calling the callback function and pass in user data. Okay, now let me create another function here, function as process user data, process user, okay, user data. This will have user and a callback. So this is user object that we will receive, and this is callback, and we will again simulate set timeout, and inside this console log processing user data for and callback user status processed. Very simple. We are not doing much thing. We again have a set timeout which has a console log processing user data for, then we call the callback and pass an updated user object with a new status property added, and this mimics a transformation step. Okay, we will create another function with the name display user data user object. Inside this we will again do console log and displaying user data user. We are done with these things. Now we call fetch user data, and inside this we pass a callback function which will receive the user data once it's fetched. Okay, so user data, okay, process user data and user data, processed data. This will have display user data and processed user data. Now actually this should be processed data. So what we are doing here, we call fetch user data and pass a callback function which will receive the user data once it is fetched. Okay, very simple. Okay, let me just in this step, and inside that callback we call process user data again passing a callback for what to do after processing. After that, finally, once the user data is processed, we call display user data to show the final result. Let me run this. Fetching user data from server, processing user data and then displaying user data. ID1 name Tekneikos, status processed. I think this should be clear, but let me explain you the flow again. So even if you have understood nothing, let me explain you again for you. I will simply come here and explain you the flow again. Okay, the flow begins when we call fetch user data. We know this must be clear to you, and we pass a callback. Inside this function we simulate an asynchronous operation using set timeout. Okay, we have studied that set timeout is a macro task and all these things, so it's an asynchronous task. So we simulate that after 2 seconds. How do I know that it's 2 seconds? Because it's 2 seconds. Okay, after 2 seconds it logs the user data has been fetched and then calls the callback with a user object. So let's see that. 1 2, yeah, it fetched user data is printed from the server and rest thing is done. Okay, after that that callback is the next function, which is process user data, which takes the user object and another callback. Again we simulate a delay with the set timeout of for around 1.5 or 1.5 seconds. It logs that it's processing the user data for, and along with that it updated the object with a status processed. This is a status property with processed. Okay, finally display user data is called, which simply logs the final result to the console. This entire chain shows how data flows through multiple asynchronous steps using callbacks. Okay, very simple. Now there is a problem, and if you have identified that problem, then that's well and good for you. The problem is you can see how quickly the nesting can grow, making the code harder to read and manage. Yeah, the code is so messy that if I create some more functions with callbacks, it will be very difficult for a beginner or someone new to understand, and even advanced people will not able to understand if it is so much messy. With that, we will understand a new thing, which is callback hell. I have created examples for you. You can see here problems with callbacks, which is callback hell. When multiple callbacks are nested within each other, it leads to callback hell, also known as pyramid of doom. Remember this. People can ask, what is pyramid of doom? Pyramid of doom is nothing but callback hell, making code harder to read, debug and maintain. So we have this. What are the drawbacks? Inversion of control. So I just created program to demonstrate callback hell. Okay, so there is a step 1 function doing something, step 2, step 3, step 4, and all these things are running like this. Okay, let me just close the terminal and run this code so that you can understand if you can. Step 1 complete, step 2 complete, step 3 complete, step 4 complete, and all steps completed. So you can see it's a very simple thing, but with so many callbacks that it become callback hell, and I am unable to understand this code if I am a beginner. So this was the demonstration of callback hell. You can write more callback programs and you can eventually turn that into callback hell. Let me open the notes. So this was about callbacks and callback hell. So these are some tasks that I am giving you. Task 1 is to double a number and then print it. Write a function double number and then callback that doubles the number and passes the result to a callback. Okay. Task 2, simulate file download. Create a function download file with file name and callback. That function simulates downloading a file with a set timeout. After 2 seconds, it should call the callback and pass a success message. Then the last one is add 2 numbers after delay. Okay, I want you to solve these 3 tasks that are actually helpful for you to understand callbacks in a much better way. So I want this tutorial to be as much interactive as you can. So pause the video and try to solve it yourself. I am going to solve the second task so that you will get some confidence if you are not able to do. So the task is to create a function that name is download file name callback that simulates downloading. Okay, read a line, start making. Okay, the more you make, the more you understand. We will create a function download file which will have file name comma callback. Till now, then we have a console log as starting download for file name. Okay, this should be this file and this should be name dot dot dot. Now we will have a set timeout. Inside this we will have console.log finished downloading then that file name. Okay, good. Now the callback file name downloaded successfully. Then this needs a time of 2 seconds. Okay, so give a time of 2 seconds. Then download file. Inside this pass document.pdf then comma message console.log callback message. Now we can run and see. Starting download for document.pdf callback message document.pdf downloaded successfully. Good, great. So I want you to solve the task number 3 and task number 1. Okay, so the next topic that we will be learning is XMLHttpRequest. This is no longer in use much, but we will understand. Then we will go to your promises async await. Okay, lot of things we will understand and use, but before that it's important to go with the XMLHttpRequest. XMLHttpRequest. Okay, now let me open the preview. Yeah, so before fetch API and promises, XMLHttpRequest XHR was used to make network requests. However, it had several downsides. So we have understood this. Let me just copy this. So what was the downside? It required multiple event listeners. The syntax was cumbersome and harder to read. It did not support promises, making chaining difficult. Okay, don't worry. First we will understand, then we will see the downside. Let me paste. Yeah. To demonstrate XMLHttpRequest, I need to do a couple of more things so that you can understand. I have already created one index.html file which has nothing, just a title GitHub data display, which will display the user information, GitHub user information, and some p tags like we will be displaying username, followers, public repository, first repository, and repo URL. Okay, very simple. We connected the XMLHttpRequest.javascript file in this, and we also created a simple basic CSS style.css, and we will display that. Let me open the live server. I should open this. You can see this is basic interface. We will create XMLHttpRequest. First we need the username of which user we want to display every information. We will use const username equals to Google. You can replace this with your GitHub username. Then we will create a function fetch data URL comma callback. Const XHR equals to new request. Okay, XMLHttpRequest. Good. Then we will open it dot open, and it should be a get request because we are fetching the data URL comma. Okay, I wanted to write URL true. Now XHR dot on ready state change equals to function. If XHR dot ready state is 4, we will do if XHR dot status is 200, then we will call back null comma, we will pass the JSON dot parse and then XHR dot response text. Okay, at this step we will write the else part callback. If this does not work, then the request failed with status, and we will show the status XHR dot status comma null. Now XHR dot on error equals to function callback network error. Good. Don't worry, I will explain you each line one by one. If you are not understanding, I will explain you. This part actually should be here. Now XHR dot send Let me format the document. Now let me explain you what is actually happening here. So if you have not understood a single line, pay attention here, okay? We start by defining a constant username Google. This is the username of the GitHub repository of Google, okay? Now, in this case, it's Google. You know that. Then we define a function called fetch data, which takes two parameter URL and callback. One is URL and another one is callback function. Inside fetch data, we create a new XMLHttpRequest object, okay, and which is an older way but still useful way to make HTTP request in JavaScript. We call xhr.open with the get method to prepare the request and set it to run, okay, asynchronously. Then we define what should happen when the state of the request changes. We check if xhr.ready state is 4, which means the operation is complete. If the request was successful, meaning the status code is 200, we call the callback with null as the error and the passed response data. If it fails, we pass an error message to the callback. We also handled the network level errors using xhr.oneError, where we pass a generic network error occurred message. Finally, we send the request using xhr.send. Very simple. We have sent the request. Now it's time to do a couple of more things. We will call the fetch data. We will pass the URL https:// we will do it. Let me open Brave browser. Yeah, Google GitHub. There it is. This is what we are looking for. Let me just copy it and paste it here, but we will not do this. Like, it should be api.github.com/users because I want to make it generic. Users/ and then I should make it username. I will pass username, okay? This one. You can replace it with your username and you will get your data. Comma, okay, comma should be here. And it will have one error, comma, user data. If we get any error, we will do document dot get element by id, and let me just first write the code because this is very simple HTML. Yeah, I have already written the code. This was the main thing that I have explained to you. This is basic HTML and DOM manipulation, okay? So we are fetching the data. This is the URI, and if we get any error, document.getElement by id, username, inner HTML, and then it will return it, okay? Document.getElement by id, the username, inner text, and user data dot login dot follower dot public repos. We are getting all these things, and again we are fetching fetch data and then repository. This time if we get error, we will return it, and const first repo, which is the 0th array, and if first repo is there, we will simply get that. Const link document.createElement, we are creating an element, a tag, and simply showing all these things. Otherwise, no repository found. This is basic DOM manipulation. I'm just using to show in the HTML. If you are not comfortable with this basic DOM manipulation, you should watch my complete JavaScript video. Then you will be very clear. Now it's time for the truth. We will save this, and let me open the index.html and open the live server. We are getting all the details. Username is Google, followers 54215, public repositories, first repository, repo link of the first repository as well. We are getting everything. Cool. So that's how XML HTTP request works. This much is important to know how the request is made, how we handle the error. These things are just basic DOM manipulations. So I hope XML HTTP request is understandable. So what is the problem here? We have seen that the syntax was cumbersome and harder to read. Definitely. If I show you the syntax of promises and async await very soon, I will be showing you that. You can differentiate that the syntax of XML HTTP request is harder compared to the promises and async await, and it did not support promises, making chaining difficult. Chaining is definitely difficult. So let's move to the next topic we have is promises. So we will create one file, promises.javascript. So a promise is an object that represents the eventual completion or failure of an asynchronous operation, and it has three states. Okay, one is pending, initial state, waiting for the operation to complete, fulfilled, operation completed successfully, rejected, operation failed. Three states. We will copy this much only. I have already written one example, different than the example I will be showing you, so you can refer this as well. So let's move, and we have three states. Promises is an object that represents the eventual completion or failure of an asynchronous operation. Very simple. So we define a function called fetch data. Now inside this function we will return a new promise. Okay, this is how we return a promise, which has two parameters, which is resolve and reject. Remember the syntax. So till now what we have done, we defined a function called fetch data, and this function returns a new promise object. Inside the promise we have two parameters, resolve and reject. These are built-in functions provided by JavaScript to indicate success or failure. We know this, very simple. Inside this we will have a set timeout function. This set timeout will have a let success equals to true, and if success, then we will do resolve data received successfully, cool. If not, else what I told, reject. Okay, either resolve or reject. This will have error fetching data. Okay, this timeout will run after 2 seconds, so we will give 2 seconds, comma. Very simple. Till now we have not done much thing. We just created a set timeout to simulate an asynchronous operation like fetching data from a server with a 2-second delay. Inside that timeout we define a variable success and set it to true. This is just for simulation. In a real world scenario, this would be based on whether the server responded correctly or not. Then what we did, we check the success variable. If it's true, we call resolve and pass in a message, data received successfully, cool. And if success were false, we would instead call reject with an error message, error fetching data, moving the promise into the rejected state. Okay, now outside this we will call the fetch data dot then, which will have data and console.log success comma data, and dot then dot catch will catch the error, console.log, okay, not console.log, console.error, failure and data. Very simple. And finally we will have a finally. Okay, so in the finally what we do console.log and promise execution completed. Yeah, you might not have understood this, but don't worry. What we are doing here, outside this function, we call the fetch data function. Of course, if we don't call, how will it execute? Okay, and it has dot then method to it. This dot then gets executed only if promise is fulfilled. Okay, it receives the resolved data and logs success along with the message. Next we chain a dot catch method. This runs only if the promise is rejected. It logs failure along with the error message. Very simple. Then we have finally dot finally block. This runs, okay, we call it block as well. Okay, dot finally block. This runs no matter what, whether the promise is fulfilled by dot then or by dot catch it rejected, it will run. Dot finally will run in irrespective of these two conditions. Okay, it simply logs that the promise execution completed. Very simple. So let me show you in action. If I run this code, we are waiting for 2 seconds. Success, data received successfully, promise execution completed. We are getting these two things. Why? Dot then is executed because it's success, true, and I told you dot finally will run at any irrespective of anything. Okay, so we received promise execution completed. Let me show you another case. If I make it false and run again, before that let me just clear the terminal. If I run again, 1 2, and there is some issue. What's the issue? Okay, I made a mistake. Okay, I made a blunder. We are passing error and I have written data. How can it get the data? This should be error as well. Okay, so if I run again, let me just clear the terminal and run again. Okay, failure, error fetching data, but still although we got a failure because of the false, but still promise execution completed. It shows promise execution completed. Dot finally block executed irrespective of whether this runs or this runs, success or failure. I hope the promises is very clear to you. So let's open the notes, guys. Preview. Yeah, so this is one example that I have written for you. You can check it out as well using promises and this. Okay, these are the methods that we have seen: dot then, dot catch, dot finally. Okay, there are some advanced promises methods like dot all, dot raise, dot any, dot all settled. Okay, but the thing is, I will not leave these things by telling you these are advanced. I will teach you these as well, because I told you this is the only asynchronous JavaScript video you need to watch. Okay, so let's move. First of all, tell me that this is very clear to you. Okay, this promise concept is very clear to you. A promise is an object that represents the eventual completion or failure of an asynchronous operation. Okay, this is very clear to you. Let's move. We will create one function called fetch user, and this time we will pass one ID. Return new promise, promise, and this time let's just have resolve, and again set timeout to simulate time, and this time we will do resolve user and then ID data comma 1000 into ID. So different delay for each. Okay, now what we will do const p1 equals to fetch user, this function 1, and copy this, paste it again and again. This will be 2 3 2 3. I always recommend to give semicolons, although it will not give any error, but it's a good practice. Now we will use the method promise.all. Okay, this resolves when all promises are resolved, fails if one fails. Let's see live example. Promise.all and an array p1 p2 p3. Okay, then dot then, we have learned this here. I told you dot then, and this will be result. Inside this console.log promise.all. Okay, I made a spelling mistake. Promise.all resolved. Very simple. And console.log. Inside this result dot catch to catch the error. One of the promise failed, and then error err. Okay, this I can write it as err. Okay, there should be a comma here. Once this is done, we have seen promise.all. We will understand this, don't worry. I will also teach you promise.any. Let's suppose we have p1 p2 p3. Inside this again the same thing. Let me copy this much, paste it here, and fix this. Let me explain you the code. So we start from here. We created a function fetch user with one ID returning a promise that simulates fetching user data based on user ID. It returns a promise that resolves after ID seconds. Okay, ID second. What is ID second? So user 1 comes back in 1 second, user 2 in 2 seconds, and so on. Okay, we created 3 promise 1, promise 2, promise 3. Now first we use promise.all and P1, P2, P3, passed all 3 promises. This waits until all promises are fulfilled. We know this, we have learned it here. This waits all promise are fulfilled. Only when every single one is done, we get an array of all results. If even one fails, the whole thing fails. Okay, so we will run this and see whether this statement is true or not. Okay, promise resolved. User data 1, user data 2, user data 3. Okay, very simple. Now let me run the any part as well. So what is happening in .any, promise.any? So it resolves as soon as first successful promise finishes. So in this case, P1, you can see user 1. Let me just clear this and run again. User 1 data, first promise.any resolved. We got the user 1 data. So what is happening? It resolved as soon as the first successful promise finishes. So in this case, P1 will likely resolve first. So what is happening? P1 gets resolved and we get this promise.any block executed, promise.any resolved. Now let's see. So there are two more left. You can understand with these two. Dot all settle resolves when all promises settle. Okay, success or failure. Dot raise resolve or reject as soon as the first promise settles. I have also written one example, promise.all versus promise.raise. Now to understand promises in a much deeper way, let me create one program that we did in XMLHttpRequest. Very similar program, same program for promises. What is that program? To get GitHub user details. Okay, we will do the same program so that you can understand promises in a much deeper way. Simply we will create a function fetch user data, and this will take username. Of course, is there any function before no? Now we will use fetch to actually fetch the data. https://api.github.com/user/our username. I will make it universal so that you can change your username and get the detail. After that, what we have learned, we will use dot then response. If we don't get any response, dot okay, it will throw new error, that http error status and response dot status. Return response dot json. We want the data in JSON. This should be response. Okay, then we will use dot then again user data. This time we will do console.log and user data, comma user data console.log username user data dot login, then again console log. We need followers, user data dot followers. The last thing we need is public repositories, user data dot public repos, and we will simply return fetch the repo link. Okay, let me just copy this and again paste it here, /repos. Again dot then response. If we don't get any response dot okay, then row new. Okay, this should be new error, http error. Okay, let me just copy the same line. Yeah, this should be like this. Okay, then we will return response dot json. At last we will do dot then again repos and console.log repositories repos. We need first repo name, comma repo 0. If it is present, we need to do some conditional rendering name, else no repositories. Again console.log. We also need first repo link, comma repos again 0, question mark dot html url, else no repositories. Finally we will do dot catch to catch error if we get any, and console dot error dot message. So we are done writing. We just need to call the function fetch user data and we will pass the username Google. Very cool. Let me save it. Okay, let's go to index.html. Here we will change the script source to promises.javascript. Yeah, and save it. We will open the live server. Copy this because we cannot open console in this browser. We will use Brave browser and paste it. Yeah, the thing is we will not get anything here because I have not mentioned, but here we are getting everything. Okay, in the console you can see the username is there, which is Google, the followers, public repositories, all the repositories. We are getting all the repositories. Okay, you can see everything is there, and we are getting the first repo name dot all star, first repo URL, and promise.any resolved user1 data. Actually, we are getting these things because of our previous programs in the promise.javascript, these programs, but don't worry about that. We are getting everything as we were getting in XMLHttpRequest. So you can see how easy to understand this code. I will explain you again if you have not understood, but you can see even a person who is not into programming, but if he sees and compare the XML request with promises, he can surely say that promises are easier in terms of syntax compared to XMLHttpRequest. So even if you have not understood anything, don't worry, I can explain you. So what we are doing here, we have created a function fetch user data and passing username, which is Google. Okay, inside this we demonstrated how we use fetch with promises to get the user data from GitHub. So it begins by making a network request to the GitHub API using the provided username. Once the response is received with fetch and .then, and if the request was successful, user.response is okay. If so, it converts the response to JSON and logs key user details like username, followers, public repositories count, and then it makes another fetch request to get users repositories. If that call succeeds, it logs the list of repository details in about the first one, name and URL. All of this is handled in a chain of .then calls again, making the sequence of asynchronous action clear. If anything goes wrong in any step, either network issue or bad response, .catch at the end will handle and log the error gracefully. This approach ensures smooth handling of sequential asynchronous operations using promises. Very clear. I think this should be clear to you. Now we will see, promises are done. Now we will see async await. Extremely important. Async await. We will create another file, async await.javascript. I don't know if I can. Okay, it created a folder and inside that a file. No, this is not what I wanted. Let me delete async await.javascript. And inside this, what is async await? Async await is syntactic sugar over promises. It's a sugar. Oh, it's not actually sugar. It means more readable and efficient syntax, making asynchronous code look synchronous, improving readability and maintainability. Let me copy this. We will paste here for your reference. So we will understand. I know you have understood the way I teach. So we will write simple program to first understand the syntax. Then we will create the same program for the GitHub user details to understand it in a much deeper way. Also, we will write a lot of practical code. Async. Okay, the syntax is async or async, whatever you call it. Function, then fetch data, function name, async function name. Inside this we will have a try block, let response equals to, then await, very important, new promise, and resolve comma reject. You can write without promise, but I am writing to demonstrate something. You will understand it. Now inside this, okay, where is the mistake? Promise new. Okay, yeah, I got it. New promise. Now inside this we will demonstrate set timeout, and inside this let success equals to true, and if success we will do resolve, promise gets resolved, data received successfully. Else what we do, we write reject, error fetching data. Very simple. Let me just make it format document. Okay, it's not working. I don't know why. My format document is not working. Okay, leave it. After this set timeout, we will give a time of 2 seconds. After this block, we will do console.log success and response comma response. This will give us an error because this should be inside this block. And catch, try. If we have a try block, we will have a catch block. Catch block will catch errors, so error, and console.log failure error. We will have one finally block as well. Okay, finally this will do console.log and promise execution completed. At the end we will do fetch data. We're done. Let me run the code. 1, 2 and success. Data received successfully. Promise execution completed. Very simple. Now I will explain you the code. So let's start explanation of this code. Although this is very clear, but I will explain you so that if anybody of you have not understood, you can understand it. Okay, it start with async keyword before the function. Usually you see function then function name, but this time we are using async keyword before the function. Okay, so why async? Because this tells JavaScript that this function will handle asynchronous operations and allow the use of await inside it. Okay, inside the function we have a try block to do basically try, and then we have a catch block. Okay, ignore that right now. We have a let response equals to await. So why there is a await? Understand await carefully. The await keyword pauses the execution of the function at that line until the promise is either resolved or rejected. Okay, until the promise either resolved or rejected, the await function holds the complete flow. Okay, so here we simulate an asynchronous operation like fetching data from a server using set timeout with a delay of 2 seconds in this much of code. In that set timeout we set a success flag to true here. If the success is true, we can resolve with the message data received successfully, which means promise is fulfilled. Otherwise it would call reject, which is error fetching data. If the promise resolved successfully, the result is stored in the response variable. I am repeating my words. If the promise resolved successfully, the result is stored in the response variable, this variable, and we log success followed by the message. If there is any error during the response, like rejected is called. So what will happen? The catch block will run and log the failure message. So if it is success and the response get the promise, it's get resolved, and this success will run. If there is any error, this catch block will run. Okay, and we get error. Regardless of success or failure, again finally block will run. Very simple code to understand. As I told you, we can use promises in async await or we can skip. It's up to us. So let me show you another example. Example number 2, in which I will not use promises. Async again function name, fetching how we use real API. Suppose this is an API request. We will have a try block. Inside try block we define what we want to try or what we want to do. Response equals to await. I told you await, and then fetch. So fetch will help us to fetch from the API or server or database, anything. Okay, some url.com. This is the site we want to fetch some data, and then let data equals to await response.json. So this line is written to convert it into JSON, but why await? So this is a good practice to write await while converting to JSON, because this also an asynchronous task. Console.log user data and then comma data. We receive the data. Once we receive the data, we can now write the catch block, catch. Okay, in the catch block we will have error and console.log error comma error. We can skip the finally block. It's up to us. So this is how we do in normal fetching APIs. We don't need promises in everything. We can write like this as well. So let's move to example number 3, which is your GitHub example. So pay attention and see how easy it is to use async await to do the same task compared to your XMLHttpRequest. Okay, again we will write async and function and then function name, fetch user data from GitHub, and then we pass the username. Simple, easy to understand. We will have a try block. We know this. Inside that try block we write the code that we want to execute, or we want the response. Let user response equals to await, and after awaiting we will fetch I told you we will fetch. We will pass the https://apis.github.com/users/ and then your username. Once we write this, we will now write conditions to check if we get that or not. User response dot okay, throw new error. If it is not okay, it will throw error. And okay, let me write http error status is your this one, and user response dot status. Okay, now we will get the data. Let user data equals to await and convert that to JSON. User response dot JSON and console dot log user data. Let me write the console logs. So I'm not doing much thing. We are getting user data, username, followers, public repositories. Once we get that, we will again make another request. Let repo response equals to await and then fetch. This time let me copy this, paste it here, and slash repos. We'll get the repositories. If again this line is similar, so I will copy this again and paste it. This should be repo response, and let repos equals to await and repo response dot JSON. This should be repo response dot status. Yes, again some console logs. Let me write. We got the repositories, we got the first repo name and first repo URL. After that, we are done with the try, whatever we wanted to do. We will write catch block with error, ERROR. And inside this, we will do console log error and comma error. And at last, we will call this function and pass the username, which is Google. Okay, and we are done. We just need to go to index.html and change this promise to async await.javascript and save this. We will open the Brave browser again. Let me refresh it. Yeah, okay, we are getting the username, we are getting the followers, public repositories, all the repositories, first repo name, first repo URL, success, data received successfully. So this is how easy it is to write with async await, doing the same task using, I have shown you doing the same task with promises, with XMLHttpRequest and with async await. So this should be extremely clear to you. You can change this to your user name and you can see your repository. Let me just take a random guy. Let me take this guy's username and we will see if it is working or not. His username is 44, paste 4. So simply we will get back to VS Code and change this to this one. Okay, let me save it. Once I save this, you can see in our HTML, we are getting his data, 301 followers, public repos, and all these things. This should be very clear to you. Let me open the notes for you. We are done with the async await thing. Error handling, we have seen this as well. Dot finally, you can use it or you can skip it. The last thing is, should you use promises or async await? Because both of these are modern and using the or working is very similar. Let me explain you this as well. Both promises and async await are effective for handling asynchronous operations in JavaScript. The choice between them depends on readability, control flow, and specific use cases rather than one being inherently better than the other. When to use promises? Useful when handling multiple parallel async operations, works well in libraries where callbacks are needed, can be used when handling event-based asynchronous tasks. You can use async await. This is best for sequential asynchronous operations, makes code look synchronous, improving readability. Easier to use with try catch for error handling. So this completes our asynchronous JavaScript. So if you have learned something valuable today, don't forget to hit the subscribe button and like the video. Also, it really helps the channel grow and motivates me to keep creating more no nonsense practical videos for you. Thanks for watching. I will see you in next one.